And in retrospect, we sort of set this up in reverse order. Earlier in the day, we had one of our former fellows, Kashka, give a presentation about the work she did last year. And now we're seeing the next generation of our current fellows talking about the work they plan to do this summer. So with that, we have two quick lightning talks. We'll get to our fellows.
Hi, everyone. I'm Snikitha, and well, I will be talking. My project is about understanding throughput using a standardized workflow. If you remember Kashika's talk, it's pretty interconnected to her project as well. And I'll be talking about how I used How many of you are aware of Monte Carlo pi estimation? Okay, cool. Okay, but I'll be talking about how I use Monte Carlo pi estimation as a standardized workflow to understand throughput. So firstly, why do we care about throughput? Well, users and admins want to know what's a normal throughput. And for that, I have an example. We have people measure our blood pressure, doctors measure our blood pressure. And so when they tell you that your blood pressure is low or high, how do they know what the normal blood pressure is? And so so that maps directly to throughput. So when the system tells you that the throughput is low or high, how do we know what the normal throughput is? So for that, we need a baseline. And so the challenges are, pools are dynamic, they're always changing. A job's total time includes waiting in the queue, not just the running time. And without a baseline, how do we know when throughput on the system is normal? So the design experiment includes fixed input and resource requests and unique seeds so that any run can be replayed exactly. And then comes timestamp ordering. We sort the timestamp by the job completion time, and repeatable runs. Multiple submissions reveal pool level variability. So the idea is throwing darts at a circle. So throwing random points into a unit square and checking if each point lands inside the circle. And the ratio of hits refers to the estimate of pi over 4. And the more points we have, the better estimate we get. And so that directly maps to the jobs. So here the random points are jobs that we submit. And so where does HT Condor come in? So we're running it at scale with HT Condor. And so step 1 is to submit X number of jobs with Y random samples per job. And you run jobs in parallel. So each job writes its output.txt file with hits, samples, and pi estimate. And then we aggregate the results. So we have an aggregate.py script that sorts jobs by completion timestamp and computes a running cumulative pi estimate. Now, the proof of concept. This is where it gets interesting. So as you see, there are 20 runs in this graph, and you see that all of them are slowly converging to the pi reference, which is the red line. And then we have another graph which calculates the absolute error versus the total number of samples. So we started with 10 to the 4, and it goes till 10 to the 6. And you see that as the number of samples increase, the absolute error is going down. So that's what we are trying to show. And so the next steps is memory profiling. So let's suppose we go to a restaurant and we want a table for 2, but we ask for a table for 8. And here is where it gets interesting. And when you ask for a table for 8, you get it, but then you might have to wait longer. And the other 6 seats gets wasted, whereas they could have been used in another for other people. So it's the same with memory, is that we observe that users are requesting a lot of memory while running jobs, and it takes longer for jobs to move through the system. And why do we really care about memory? Again, we ask for too much, so fewer machines can fit your job, and it goes to longer wait times. And if you ask for too little, then your job is just put on hold. And so memory requests directly change how many jobs finish per hour. So what we're going to do now is run the same workload with different memory requests and measure how throughput changes. And so the goal is to build a memory profile so that it helps our users, which is all of you, to understand how memory affects your throughput and to be able to make reasonable memory requests. But yeah, thank you. And also, I would love your feedback on this because you are our real users. So coming from you, I'm still just starting off. I'm 3 weeks in. So I would love to learn a lot more about it from you guys. Yeah, thank you.
If there are any questions, you can ask them. For all of them? Okay. I guess you can disperse for now.
Hi everyone. Okay. Hi everyone. My name is Daniella. I am a student here at UW-Madison. I am majoring in computer science and data science, and I am one of the fellows that will be working here with CHTC during the summer. So I will talk a little bit about my project called Bites of Knowledge. So the motivation behind this project comes from a common challenge faced by users when reading documentation. So whether they are learning research computing for the first time or they are returning to concepts, locating and absorbing the information that they're looking for can sometimes be difficult and time-consuming. So we've taken a look at the documentation that we have on the CHTC website, and we have seen that some pages are text-heavy, overly verbose, and or filled with technical jargon. So that brings me to the objective of the project. I plan on making the documentation easier to parse so users can get the information that they're looking for quickly. I currently have two main areas of focus. My first area is the roadmap to getting started. This is a page that the facilitation team often points beginners to. And then I also plan on creating a dedicated frequently asked questions page. So this is what the roadmap to getting started currently looks like. We see that there is a lot of text, there are sections, and the idea is to break this down into different pages and to incorporate graphics and elements. So here are a few examples. We have code blocks, warning and tip messages, and then also figures like the one over there. So that is something that I created. I have some experience in graphic design, and I look forward to creating more. This data lifecycle aims to illustrate the best data handling practices for users. I will also be incorporating clearer writing, more specifically plain language. I added a definition here that is taken from the United States Office of Personnel Management. But plain writing is writing that aims to be easily used, read, and understood by users while still maintaining professionalism and technical correctness. And for my second focus, I will be creating a dedicated frequently asked questions page. And here I plan on collecting frequently asked questions from users that we have received during office hours or support tickets. And here are a few questions that I came up with while learning research computing CHTC for the first time. So we have, am I eligible for a CHTC account? How long does it take for my jobs to start? And where can I get help if I get stuck? And finally, we have the assessment part of the project. I intend to measure the impact through analyzing trends in website activity and questions that we have received during office hours and support tickets. This would be my quantitative measure. And then for the qualitative measure, I plan on interviewing users to collect their feedback that they have on the documentation. Thank you, and I'm happy to answer any questions that you may have.
Have any questions for either of our fellows? Well, with that, sorry, Brian? Someone on a mic? Oh, our fellows were carrying the mic. We have a bit of a deadlock.
So for Snikitha, you mentioned measuring different memory profiles, trying to understand how memory requests can affect throughput. Have you thought of other dimensions, or do you expect everything to behave like memory, or are there other aspects that you might think about in the future?
So I was thinking of like we can also target other resource requests that we make apart from memory, just like the number of CPUs and so on. But yeah, that's where I'm trying to profile every resource request so that you can maximize your throughput by understanding it better. Yeah.
So in high energy physics, we think of throughputs in the metric of events per second that are processed through the system. And I think I got from your talk that you're talking about sort of jobs per hour or, some unit of time. Is that right? You just want to look at the jobs, or is it something else that you're measuring?
No, right now we're just seeing how does the number of jobs, and in this case I'm also, for each job I'm trying to measure vary the number of samples as well. So I'm trying to understand how does that affect throughput. And when you're submitting a job, there's various resource requests that you make, right? So we're trying to go deeper into this and try how does each resource request affect throughput is what we're trying to understand. Does that answer?
Well, I'm still fuzzy then on
Okay.
what the definition of throughput is for you.
What?
What is the definition of throughput?
Well, if I understood it, if I understood it correctly, it's the number of jobs that go through the system with a set
Okay.
amount of time.
So in a certain amount of time.
Yeah.
But then doesn't it also depend on the length of those jobs? Like how long it takes to execute?
Sure. Yeah.
So the only reason this works then is because you have the standard calculation of pi. Is that right?
Yes.
Okay, thanks.
Thank you.
Yeah, Danny?
Yeah, so when you're talking about memory, calculating memory usage, are you looking at peak memory usage, average? I'm thinking of certain programs, you'll see very low memory utilization, and then like the last 10 seconds of the job, it peaks out because that's where like all of the heavy calculation is doing. So I'm wondering how you're kind of calculating that metric as the job is going through.
That's something I will definitely look into, but
Yeah.
if I understood it right, like at least what I'm thinking to do is go from like a minimum amount of memory maybe, and then go keep increasing it and see how that affects.
Gotcha.
And well, repeat this experiment and see where.
Yeah.
Yeah.
Yeah, we should chat sometime.
Okay. Yeah. Thank you.
Great job.
I have a question. This one's actually for you, Danielle. Writing good documentation is difficult.
Yeah.
I'm sure a lot of us in here know this. Do you think that by the end of this fellowship, you might be able to maybe piece together maybe a simple like guideline of how to make good docs, like standards of voice and like when to use images and how difficult the complex those images should be and stuff?
Yeah, I think that's a very good idea. I do have some experience writing teaching material through my other job, so I would be happy to work on something like that. That's a good idea. Thank you.
My question is also about documentation. First of all, if you end up writing something like that, please share it with the community and please have Christina send it to me because at Georgia Tech, we would be very interested in a document like that. It's just a great way to standardize your documentation. I was kind of interested in understanding the logic behind breaking the roadmap guide, which my understanding is like a 10-step guide, if I recall correctly, into 10 individual guides. Uh, personally, I sometimes have a hard time with getting somebody to go through 2 guides, let alone like 10 different locations. So I was just wondering if you could kind of chat about how you came to that conclusion.
Yeah, so I think the main reason for that is because first this is like introductory material. So I was planning on incorporating visuals like that little figure that I added, which I hope that makes the concepts like that more clear to the audience, to the beginner audience. So I'm thinking that once I have all these 10 steps and visuals in some of them, it might be a very, very long page. So splitting it into 10 separate pages might make the navigation easier. So is there, if there is a specific topic you would like to know more about, you have that page for it. Yeah.
I also have a question about sort of the docs part. So for me, at least, it's very easy sometimes to just put out a bunch of docs, write it up, put it on the page, and then a couple months later, I'm talking to a user, they're like, I started looking at this and then I navigated away or I was overwhelmed. What sort of feedback and how are you testing that your redesign is improving user
Yeah.
readability and engagement?
Yeah, so that's something I am still thinking about. I do plan on looking at website views and I guess relating them to the questions that the facilitation team are receiving during office hours. The specific approach to that is not set yet, but I do plan on getting the quantitative and the qualitative side of that topic that you're asking for. Yeah.
Something that I would recommend, and I'm sure that all of the facilitators are happy to help. Most of our users are actually really happy to sit down with one of us and like go through some of these pages and give us their like unfettered feedback. And so if that's useful, that's something that we might be able to arrange with some of the kind of broader community outreach programs that we have, whether it's through Bioinformatics Cafe, with some of the other community associations that we have here at CHTC, to get a couple users and just say, here's some docs, tell us what you think. And that way you have sort of like live feedback.
Yeah, thank you.
Yeah,